formulae with squares and square roots. Example 1. Make a the subject in the equation 2a square minus 1 equals 71. 2a square minus 1 equals 71. By the law of inverse, we have to add 1 to the 71 because 1 is subtracting. So we have 2a square equals 72. Using the same inverse, we have 2 multiplying a square, so 2 has to move and divide 72, and that gives us 36. So, we have a square equals 36. Now, we are to make a standalone from the a square, so moving the square to the other side gives us the square root of 36. So, we have a equals the root of 36. Since 6 times 6 is 36, we say the square root of 36 is 6. Therefore, a equals 6. Example 2. Make a the subject in Q equals the square root of a over 4. Q equals the square root of a over 4. By the law of inverse, we have to remove the square root by squaring the both sides. Note, the square of the root of a over 4 is the same a over 4, and square of q is q square. So, we have to put down our q square equals a over 4. Now, we have to make a, which is a numerator, a standalone. So, the 4, which is dividing by inverse, must now multiply q square. Therefore, 4q square equals a. Example 3. Make r the subject in the formula a equals by r square. A equals by r square. Here, by the law of inverse, we have to multiply or divide both sides by pi, and since pi is multiplying, it has to divide. So, we have a over pi equals by r square over pi. We realized here that pi and pi can cancel itself, so we have cancelled pi and pi. We now have a over pi equals by r square. To make the r a standalone, we have to by the law of inverse find the square root of a over pi. So, the square root of a over pi equals r.